I am biophysics teacher Anel Narjana. Today we discussed about basic biological effects of ionizing radiation. So, biological effects of radiations. What does mean ionization radiations? Ionization radiation have many beneficial applications, but they also have the detrimental consequences for human health and for environment. Since X-rays were discovered in 1895, it was quickly realized that they may be harmful. To protect people and the environment, and we should know how radiation-induced effects occurs. And these pictures we see who opens radiation. Yes, Marie Curie, X-rays, and etc. And the rentgens. Yes. So, what is ionization radiation? To understanding, we see pictures. And ionization radiations, it means if the positive energy is high enough to ionize the transversal materials, and the types will be electromagnetic, X-rays, and the gamma rays, and the particles alpha, beta, and neutrons. Each type interacts its own way with the materials. Yes, from this picture we can see paper can stop alpha particles, but beta particles can be stopped by aluminium. What about X-rays and gamma rays? It means it has good penetrating, yes? And now we see from this picture, X-rays and gamma rays has good penetratings. And that's why X-rays and gamma rays is harmful for human body. Interaction of ionization radiation with matter. Photons. What does mean photons? For energies lower than 50 mega electron volts, there are three main processes by which photons interact with matter. It's a photoelectric effect, Compton scattering, and the pair production. And the photoelectric effect, it means indecent photon is a thought absorbed and eject electron from atom, and this effect dominates with a low energy photon interacting with the heavier elements. Compton scattering is electron is also ejected, but indecent photon survives and is scattered by losing some of energy. And what biological tissues this effect dominated energies about 50 keV. And the pair production, it does mean is process in which its energy converted into electron-positron pair, and the interaction starts occurring at energies higher than 1 MeV. Unlike electron-positron, while eventually disappear and annihilating one electron of surrounding materials. Positron-electron pairs is converted to photons with energy about 0.5 MeV. And the neutrons. Neutrons is interact with nucleus, elastic and elastic diffusion, nuclear reactions and capture, and produce emission of secondary charged particles like protons, alpha particles, and etc., which are responsible for tissue ionization and for biological effects. From this picture we see elastic diffusion with production of protons and another neutrons, and from this picture collision with nucleus with the production of various charged particles, protons, nuclear fragments, and electrons. Charged particles, these interact with nucleus and to great extent with electrons, and they slow down energy deposited per depth, or let increase until the particles come to halt, and the sudden peak of energy, like this one, break peak. We can call it the break peak. When they have sudden peak of energy, it's called like a break peak. Units of radioactivity. The radioactive decay is a process by which atom molecules and stable atom loses energy by emitting ionizing particles. And the important measure is the activity, and the activity measured by Becquerel. This example for radioactive decays. We get cobalt-60 decays emitting by beta particles, and radium-26 decay emitting in alpha particles decays. And the numbers of radioactive atoms decreased by expansional decays will be by expansional decays. And I get it is from articles, and I put these articles links. From links you can read it. The radioactive atoms will be like a decrease expansionals. This side is the time or half-life. This side is the properties of atoms left. And the quantities used in radiation studies, amount of producing effects specified as energy deposited per unit mass in irradiated materials, and this is absorbed dose. It means energy absorbed in mass, and the dose measured by Gray or just joule by divided kilogram. And however, for instance, linear energy transfer is measured energy transferred by ionizing particles to traversed materials. This measure is typically used to quantify effects of ionizing radiation on biological specimens, and usually expressed in units keV divided by mu. When we have low linear energy transfer, it means X and gamma rays passive linear radiation, and the energy is distributed by homogeneously. And when we have high linear energy transfer, this is inhomogeneously. Energy is distributed inhomogeneously. From this picture, we can see to normalize the rate of biological effectiveness used. RBA, relative biological effective, it means dependence. Dose and the X-rays required to cause effects, and dose divided, dose of X-rays required of cause effects divided by dose of radiation required to cause effects. And the relations between RBA and the LET, it says from this picture we can see between this relation RB and the LET. Equivalent dose, it is judged quantity for assessing health risk of radiation exposure. And equivalent dose, it is cannot be measured directly. Dose for each tissues and each type of radiation is calculated by this equation. And the radiation quality and witness factors will be different. It's for radiation types, photons, energies, also, and their factors will be different. And radiations and can be damaged DNA. Here shows what happens when damages human karyotypes. Yes, human karyotypes are damaged by radiations. It shows how should say it's a human chromosomes are normally combined into 7 groups from A to G plus pair of sex hormones X and Y, and the chromosome groups R1, R3, B, 4 and 5, C is 6, 12, D is 13, 15 and etc. Energy deposit in and near DNA. From this picture we can see how the electrons damage DNA. Ionization radiation produces energy deposit events on time and space. DNA damaged directly. And direction action of radiation dominate process for high lead, such as neutrons or alpha particles are for lead. For low lead, the radiation direct action represented about 20% and indirect action is about 80%. From this equation we can see water radicals caution is very strong acid that loses protons to neighboring water molecules and forms OH radicals, which oxidating agent 3, 4. That is probably the most damaging radicals. Damage DNA. How will we change low lead radiation? Can we produce a localized cluster of ionizations within single electron track? A high lead radiations produce somewhat larger number of ionizations that are closer together. Yes, ionization radiations and the excitation. So types of DNA relations damage types, the base damage BD, amount of damage is 1000 to 2000, and the estimate of number of radiation indicate different types of DNA lesions, up to 1 grade irradiation with low lead radiation. Cell has complex signal transduction, cell cycles, checkpoints, and the repair pathway to respond to DNA damage. DNA damage include exogenous agents and endogenous agents. And the exogenous agents by damage by ultraviolet ionization, chemicals, and etc. And the endogenous agents reactive oxygen specific nitric oxidants. And the cell cycles and the checkpoints when the cells damage from radiation, how will be changes the cells cycles and their checkpoint. The SB are critical DNA lesions. Their missile repair or non-repair leads to formations of aberrations like dysentrics. There are two main mechanisms to repair DCB: is a homologous recombinations HR and the non-homologous end joining. And from this picture we can see non-homologous and non-homologous end joinings. So today we completed today's our topics: radiations, ionization, and their biological effects. But radiations has advantage and disadvantage. Advantage if you got a lot of radiations, it will be bad for our health because our health tissue cells started damage from radiations. For advantage, it means we can use the radiation for therapy and for diagnosis methods.